Hi everyone, my name is Joshua from TAG, and in this video I will be teaching on the topic the usage of the can't function in R programming. And so for the purpose of this tutorial, the data set we'll be using is the Chick WTS data set that is freely available in R in the data set package. And this data was collected from an experiment conducted to measure and compare the effectiveness of various feed supplements on the growth rates of chickens. So let us store the entire data in a variable called DAT. And so when you check the global environment, you would see that the data has 71 observations of two variables, which is what you can easily get using the dimension function. So it gives you the dimension of the data. So let's have an idea of the head of the data, like to have an understanding of the columns we have in the data. So we could see that we just have two columns, one for weight and the other for feed. So we have an understanding that the feed are of different levels. So let us check the structure before we use the level function. Let's check the structure of that to see the class of each of these variables. So we could see that weight is in the right class, is in numeric, and feed is already factored. So for us to have an understanding of the unique levels of feeds, we have to say levels that $, and then we go with feed. And so we could see that it has just 6 levels: casein, horse bean, linseed, meat meal, soybean, and sunflower. So as it is very easy for us to perform summary statistics on numeric variable, when it comes to categorical variable, one of the very elementary summary statistics that we can perform on categorical variable is this concept of count. So let us have an understanding first with summary statistics on the numeric variable we have in this data set. And so our idea is to understand the mean of the chick weight on the basis of the feed, the mean weight of the chick on the basis of the feed. So what we are going to do in this case would be to say mean, and then we say that $ weight, and so we index for feed that is equal to casein. Let's start with casein, and so if you run this, we have 323.5833. that is the mean weight for like feed that is belonging to casein. So if we are to check again the mean weight for other feeds, to make this very fast, I just copy and then I paste, and so I change the name of this to horse bean, and then I paste again, and then I change the name to linseed. So this is what you're going to do for the rest 3 levels of the feeds, but this can be time wasting. So there is a function called apply from the base package. It belongs to the apply family, and so the first argument it takes is going to be the vector of weight, which is the numeric, and then the next it takes as the index is the grouping variable. In this case we are grouping by the feeds, and so the next it takes is the kind of function you want to perform on the vector of the weight. So we want to just get the mean. So then when you run this all at once, you have the mean weight of the chick on the basis of feeds. So let us now understand how we can perform summary statistics on categorical variable, which in this case is the second column, which is feed. So we have this function called table from the base package, and so this is also one of the very useful functions that you can use when it comes to having an understanding of the frequency table for categorical variables. So if you see this $feed, and you could see that for the first level we just have 12 observations for casein, for horse bean we have 10, for linseed 12, meat meal 11, soybean, and then sunflower 12. So let us now try to do some of these things in the tidy way. So we're going to use a package called tidyverse that has with it a lot of packages again activated as soon as we load it. So what we are going to do is we're going to use the count function from the dplyr package. So what I'm going to do here is to say that $ simple, let's just say count. What are we counting? We are counting the column called feed. So if you run this, you have this particular result that we're seeing on our console. So again, you can do this by using this function called group by from the dplyr package. So we are grouping by the feed, just like what we did when using the tapply function. So we're grouping by feed, and so what are we doing? We are counting whatever result we have from the grouping with the feed. So as much as we can use the count, there is also another interesting function again that performs exactly what count does, and that is tally. So let's say we have that $, and then we say tally. Let's see what will happen. So when I run this line of code, we could see that tally gives us something quite different. And so one thing we must understand when using tally is that it assumes that the variables are grouped. So we're going to have a different result if we group them and say group by feed, and then we use tally function coming from the dplyr. So here we have the result in the form of a table, and you could see casing 12, husband, the count is 10, exactly with what we have achieved before. So it is also possible for us to sort this particular count. So what we need to do, let me copy what we have in line 19. So then I paste it down here. All I need to do is to come here and just include an additional argument called sort and turn it to be true. So when I run this, you would see that everything is now arranged from the bigger value down to the one with the smaller count. So again, there is another function again that is available with this count function in R, and it is called the add_count, and this does exactly what the mutate function from dplyr does. So this is what we're going to do. We're going to say that again, and then we pipe, and so we say add_count, and so we're counting on the basis of feed, and so we're creating a new variable. Like I said, it acts exactly like what the mutate function does. So we're going to say WGT, like we are converting the weight to kilogram. We are assuming that the existing weight before was measured in gram. So what we're going to do is to say weight divided by 1000. So if I run this entire line of code, we're going to have this result that creates a new column for the new weight converted to kilogram, and then it gives the count for each of the individual rows. So this is the way to which you can use the count function in R programming, and I want to say a big thank you for taking our time to learn R with me. See you in the next video. Ciao.